So hello everyone, hopefully you are able to hear me. Uh, Today we are going to start using LibreOffice Base. In Lab 1 we were using Draw.io to draw ER diagrams, and in rest of the labs we are going to use the LibreOffice Base software, which is designed to create databases. And with this tool we can create our tables, define relationships, include all of our queries. We can also design user interfaces, and all of these functions are included as just one file. So this is going to be for your projects. At the end, what you upload is going to be one file that includes everything. So today will be an introduction to this base. We were earlier using Microsoft Access, but it's no longer provided by the university, so we have this alternative with similar functions, and it's free. And if you did not install it on your computers, please follow this guide and install it. The installation process is simple actually. Just one step to be careful about is you need to also install JDK on your computer so that this can run, and it's an additional thing to download and install from this step number 21. Other than that, it's simple how to install it. And we also include the backup videos on the website, on the TA's website. So if you need to refer back to these backups, or we also include the handouts here. And for these recordings, so I'm also recording while I tell you during the labs with a different software. That's why you are not seeing the Zoom recording sign, but those recordings are also available here. So this is from Lab 1, from different sections. We try to cover the same topic, but maybe there is some slight difference that we mention. If you need to revisit that specific meeting, these are here as well. So today we are going to start implementing a new database. We will start by creating our tables. This handout is also including some steps for how to create tables, how to create queries, etc. We are not going to directly follow it, but we will cover all the topics of it. If we go back to our ER diagram, in the ER diagram, we were using different symbols to mean different things. So we had entities, we had relationships, special kinds of relationships, and we also showed attributes of an entity or a relationship with ellipse shapes. In the ER diagram, we have entities and relationships. We have some logical distinction between those. But when we come into base, we are going to use tables for entities, and we are going to use tables for relationships. And uh, to create this logical difference, we are going to define some links, and with those links, one side will be the parent and the other side will be the child, so that, for example, consider such a relationship like enrolled. So students are enrolled into courses. If I say I keep all my students in an Excel table, and I keep all my courses in another table, and for the enrolled relation I also use a different table. In this table I keep the student's ID and the course's code, which is the primary key of the course. In such a table, if I'm using such a table, then when I enter some new entry to this enrolled table, for example, I enter student number 5. I would like to assign student number 5 to some course. In this case, the student number 5 should exist inside the student relation, student entity. Otherwise, I'm doing something wrong, right? With the database, we are going to enforce that whenever I try to enter something into the table of the relationship, the thing that I try to enter here should exist first in the parent side. So we will cover these and they will be more clear, I hope. So I will run LibreOffice Base, and LibreOffice is like an office package with lots of different software in it, but what we are going to use is Base only. When you run it, so right now it says that I have some document recovery. It should not appear with yours. So let me just quickly get rid of it. When you open it first, this will be the view that you see. And you have the option to open an existing database file, but we will go with create a new database. And the default options are okay for us. So I will click on next. So if I wanted to open an existing database, I just need to choose open an existing database and choose my database file, and we will go with the existing options. And after clicking on next, we want to register the database file, so it sets on the backend some things. And when you click on finish, you will open the database for editing, but it first saves a file. So I mentioned a file that includes everything, so this is that file. So let's save it maybe as lab2 example, and the extension is ODB. So I'm going to save it, and this is the view that we see. So in Base, we have these different parts for tables, queries, forms, and reports. With reports, we are not going to use in this course, but with tables, we are going to create our entities, relationships, and what we have in the ER diagram. So basically, in a database, we show what we store in the ER diagram, and with tables, we create those things. We are going to define relationships between our tables. So in the ER diagram, a relationship was a special kind of table, but we are going to define all these links that combine different tables using the relationships view in Base. We have the option to create queries, and with queries we can use directly SQL, or we might use the design view. We are going to cover the design view today. And in the further stages with forms, we create a user interface so that the user can use the database in a better fashion. So the last two labs will cover topics from this. But I would like to first create my table. So under tables, I have the option to create table in design view. For all of the settings, there are several ways of doing the same thing, but we are going to introduce one or two of them, and the things that we introduce are usually the more convenient ones. So I'm going to create table in design view, and with each of these options, when you are creating something, when you are designing something, it opens as a different window. So I have still access to my main window. I have access to all of these functionalities, and on top of that, this table design is the new table that I would like to create. And in here, I have a bunch of rows and columns. So with each row, they correspond to different attributes of my table. So this is going to be my table. It can be an entity. So I might be designing a table for an entity, or it could be for some relationship. But each of these could have attributes, right? For user table, I have some attributes. For relationships, I can include any number of attributes as well. And these are those attributes. And field name is the name of the attribute. So you can use field and attributes interchangeably. They mean the same thing. In Base, they are referred to as fields. So if this is my, for example, user entity, I can start with the primary key ID, for example. And in an ER diagram, we are not specifically talking about the types of our attributes, but in the database, we have to specify the data type, otherwise we don't know what to store in there. So with an ID, if you click on the field type, there are several different data types. So the type of the data that I would like to store in this attribute. So it could be a number, for example, it could be text, etc. And among these, only a couple of them are used in this course. So, uh, like we usually don't care about the range of the number, so we just go with the number for numeric data. We have the text option. With text, there is the case sensitive one, and there is the other one that ignores the case. You may decide based on your application, so whether you want to mean different things with capital letters. If you choose the ignore case one, for example, if you write Ali with a capital A and with a small letter a, they will be the same thing, but with the other one, the uppercase and lowercase letters will differ. We sometimes use the Boolean type, the true, false, or yes, no type, and you might need to use the date type, but other than that, the other ones are not that used in this course. So for ID, let's go with a number. But with some IDs, you might also use text data if you are to include letters in it, or if it is too long, you might want to consider using text again. With all of your attributes, so I'm on this first row now, sorry. Uh, while a row is selected, you have additional properties for that attribute. For example, for every different kind of data type, we have entry required. So entry required means that to create a new entry in this table, do I have to give something, give some value for this attribute? So think of an example like I create a new user. If I don't want to be able to create a new user without writing some ID, then I might make it required. Or in the case of a primary key, this is automatically assigned as required. So with length, it defines the number of decimals for a number of decimals that you can include. So how long data you can store in here. And with the other ones, we are not that interested, but this is like the after the comma, how many places you can insert, and if you do not enter something into the cell, what is the default value. And this shows an example of the formatting of the data. For example, for dates, it will show you how to use the delimiters for like the days, the month, and then the year are the symbols, dots, for example, it will show that. So let me create another attribute. So I just go into the second row and write name. And let's go with text in this case. Maybe we can make it the ignore case one, so that the capital and small letters are the same. Let me also include the surname, and let's make it ignore case as well. But for example, for password, so in our user table, we also had a password. And for password, ignore case is not a good option. I will go with the other one. So whether you use the capital or the small letters would make a difference with the password. And with all of these, actually, in order to create a new user, I want that user to have a name, so I will make it required. I also want that user to have a surname. Otherwise, if I have some users without names and surnames, I think it's not that meaningful. That's why I set as entry required. And I need to assign some primary key for my table. For all of the tables, we need to assign some primary key. It can be just one attribute or a combination of different attributes. In the ER diagram, for entities, we already show the primary key. So for example, for the user table, it's ID. For children of some entity, for example, for staff, we know that we inherit these attributes, so that for staff as well, I can guess that I need something like ID when I'm creating those tables. But for relationships, we are not explicitly showing the primary keys. We store some foreign key inside relationships. For example, even for uh, the relation enrolled, for example. In enrolled, the links between student and enrolled show me that I store some foreign key inside enrolled that references the primary key of the student. And with this link, I'm saying that I store a foreign key inside enrolled that references the primary key of the course. So we are not explicitly showing these attributes, these additional things, but when we are creating the tables, we need to be aware of them. And when we are creating a relationship, we will see them. But for this entity, again, I need some primary key. For all the tables, to be able to choose some unique rows, I need the primary key. And for this table, it is going to be ID. To assign a primary key, I right-click on this gray square next to the field name and choose primary key. So you will see it as a key icon. And while this line is selected, I no longer see the entry required part, because if it is the primary key, it's automatically required. If I want to assign something else as the primary key, I can right click on it and assign it as the primary key, but this removes the primary key icon from the other attribute. If I want to assign multiple things as my primary key, then what I need to do is hold my control key on the keyboard and choose multiple lines here, and then release the control key and right click on this gray rectangle and choose primary key, so that multiple attributes, this is going to be a composite primary key in this case. But for this table, I just need to assign ID as my primary key, so I just right click on here and assign it as the primary key. So I'm done with this table, and now I will save it. If you click on the save button, you have the option to give a name to your table, and with this naming and with all of the naming conventions, it is better to use no empty spaces. So this is going to be my user table. If you, for example, leave some empty spaces, it may not cause problems at the beginning, but in the later stages we are going to when we are going to use some programming, it might cause problems. So with all of your names, make sure that you don't leave any empty spaces. This is also valid for the field names, for example. So this is going to be my user table. And when I click on OK and close this, if I go back to my main window, I see my user table under tables here. So if I want to go back to editing, I can right click on the table name and choose edit. For example, if I need to add an additional attribute, for example, let's also add some credits. This is going to be like the scholarship, something like that. So let's make it a number, for example, and save it back, and I will close it. So I am able to add new attributes. If I double click on this table name, or if I right click and choose open, then this will open it in the datasheet view. So it says the data view. This is similar to an Excel sheet where you are able to enter some new data into your table. So maybe, for example, I can write ID number 1. I can give some name, some surname, not name. So some surname and some password, for example, and some credits. While you see this pencil icon on the row that you are editing, it means that we did not check the data yet. So remember, we will have some rules for our tables. For now, I just have the primary key, and the primary key cannot have any duplicate values. This is what I know. And then for name, surname, and password, we actually made them required. We cannot leave them empty. But while you see this pencil icon, it means that you are still editing this row, and it did not check for validity yet. So when I try to go out of this row, if I click on the second row, for example, the pencil icon is gone, and we successfully inserted this new data. Let's also try with some ID number 1, some other user, for example, with some credits. When I try to go out of this row, This time I will get an error because of the IDs. So the error message says that it will create duplicate values for the ID column, but it should be unique. It was our primary key. That's the error we get. So if I click on OK, I need to fix it. Let's change it into 2, for example. Let's have some other user as well. And let me leave password and credits empty. If I try to go out of this row, this time I get a different error. It says that I'm attempting to insert a null value, meaning that I'm trying to leave something empty into a non-nullable column. So that column is required. The password actually is required. I have to write some password, otherwise I cannot enter this data. This is the error for that. If I enter some password here, then I can go out of this row because credits is not required. If I go back to my user table in edit view, I see that for credits entry is not required, so that I can have some credits empty. One thing to be careful about when you start entering some data in your tables, if you, for example, go back to editing it, make sure that these operations will be correct for the existing data. For example, if I try to make credits required now, then one of my rows will have a problem about that. And usually it's a good idea to first design the tables, and at the end, after you create your relationships, etc., at the end, enter the data. Otherwise, if you switch back and forth, you need to be careful that what you enter here is going to follow the new rules. So in that case, either enter some credit amount for Mehmet, or you might like get rid of this row, and then after you create the new rules, for example, you can enter new data. So if I close this data view and look at the user table again, what I insert here is automatically inserted into the database. The tables are directly changed, so that they change directly. I don't need to save the data view, but that's one thing to be careful about. If I were to, for example, right click on this gray rectangle and delete this row, so I'm about to delete this row, okay. If you delete it, there is no simple undo option. So if under the edit, there is no undo for this input output things, because these are direct operations on the database. It changes some data in your database, and it makes it with queries. So with an insertion query, you insert things. With a deletion query, it automatically deletes. So when you right click and delete something, it in the backend there are some queries doing the job. Therefore, you do not have simple undo options. So be careful about it. If you have like lots of tables, lots of data in your database, when you are trying to delete something, be careful about that. Now we are going to let's get Mehmet back again, and so I don't need to save, right? When I enter something, it changes automatically. I'm going to also create a course table, and I would like to create a relation in between user and courses, similar to enroll. So I want to assign those users into courses, but first let's create the course table. Under tables, I have the create table in design view again, and for a course similar to, actually unlike this, so we were keeping the course code, course name, and description in one entity. Let's say that we also need to use different sections for a course. And usually it's a better idea to have a different entity for different sections. So let me first do it, then discuss it. For course code, let's say it is going to be a text. And let me also include the section, which is going to be a number. I make course code text because it is going to include letters and numbers. Let's also have some description in here for a course. And in this table, if you were to, let me get a notepad. So for example, if we were to include our courses like CS281, we also want to include the sections. If we have things like this, then different sections should mean a new entry, right? So for example, if I have Math 101, etc., this is going to be my course code and this is going to be the section number I have. So I want to be able to include different sections of the same course code. So in such a table, actually I'm talking about a component primary key. These two attributes should become my primary key, so that if I were to, sorry, let me do it like this. This is the course code, and this is the section number. In this, if I were to say that course code is the single primary key, then these course code by itself cannot be able to repeat. So I cannot have CS281 twice if course code was my single primary key. But to be able to refer to different sections, I need to make both section and the course code my primary key. So in this part, I will hold my control key and choose two rows, course code and section, and right click on this gray rectangle to assign these two as my primary key. So together they will be the primary key. But this is not a good way to implement things. So for the sake of the example, for this setup, if you were to include section number as a different thing in the same table, you also have the description. So for example, for this same course, maybe the description is the same, right? The section does not change the description actually. And we will have some repeating data in our database, which is not that efficient. But right now we are not considered about that. We would like to give some example that uses a composite primary key. That's why we would like to include the section. Normally, to include the different sections, what I would do is to create a different relation and table to connect new sections to courses, so that I can keep the description together with the course code, for example, and the section information could be on some separate table, so that I do not have duplicate data for this. So for example, if we have lots of different sections, I will be repeating the same information lots of times, which is not that good. But for the sake of example, now we are going with this kind of design. So I assign these as my primary key, and for description, let's say it is not required. So I'm going to save this table and give the name course to it. Let me also close this and come to the course table. Let's create some courses like CS281, section number 1, maybe with the description database, if I can write correctly. So for the same course code, I can have different sections which is okay. If I try to enter the same course code and the same section, for example, as a tuple, these are not able to have duplicates, right? When I try to go out of this row, this time it will give us an error saying that it will create duplicate values for the columns, course code, and section. So as a tuple, these two things together cannot repeat. I already have CS281 and section 2, and I cannot have it again. I can have them with different sections or with different courses. For example, in this case, let's make it Math 101. Let's also some more additional courses. And now I would like to create some relation in between course and student. So relations are going to be tables as well, we just mentioned. So I'm going to create table in design view. This is going to be my relation enrolled. And in such a relationship, kind of similar to what we discussed here, I do not explicitly show all the attributes. So in such a view, actually what I have is a foreign key to both sides. In our case as well, I need some foreign key that references the user table. And if I look into the user table, my primary key was ID. So to be able to refer a user in this new table, I need some sort of ID, because ID of the user should be stored here so that I can assign this user into some courses. The field name does not have to be the same, but if you use the same naming, it will be easier to create the links in the later stages, so that you can you can understand that these IDs should match when you are making join operations, for example. But their data types should match as well. So ID of the user was number, so ID in here is going to be a number as well, because in order to be able to join them, their data type should be the same. So inside this table, this is my foreign key. This is going to be used as a foreign key that references the primary key of the user, which was ID. But I also need a link to course. If I open course in edit view, if you remember, in the course table, we have a composite primary key. Two things are my primary key. So I need these two things as my foreign key inside this new table, so that I will be able to choose a unique course. So if I have just the course code, for example, if this is my data, if I have only the course code, I cannot select a unique row here, because course code by itself can have duplicates. But if I combine course code and section together, then I am able to choose a unique row. So I need these both things, course code with matching data types. So course code in course table is a text, and in here it is going to be a text as well. I also need the section, which is going to be a number in this table as well. Let's also include some grade, and let's make it a number. This is going to be my new table for the relationship enrolled. And if you look into the cardinality, if you are enrolling students into courses, it's usually many-to-many, right? One student can enroll to many courses, and in a course there could be many students. So we are going to make this many-to-many as well. And if we were to think about it, so let me get this new table. If you are to think about it, in such a table, if I were to enter some data, what I need to write is the ID of the user. For example, user number 5. I need the course code, CS281, and also the section, maybe section 1. The grade can be empty. Let's leave it as empty for now. So this is my user ID, and then the course code and the section. If this is many-to-many, I can enroll the same student into different courses, for example. Or I can enroll different students into the same course. So if you consider such data, course code by itself can repeat, section by itself can repeat, user ID by itself can repeat. But these three things together should not repeat again, because I already enrolled this student into this course, so that I don't need to enroll this student into this course again. Maybe if you would like to disallow that, so right now let's say whether you want to enroll the same student into different sections of the course, whether you allow this or not. It's something you decide based on the primary key of this table. If the primary key of this table is user ID plus the course code, then this is not going to be valid as well, because as these two things, they are repeating. So maybe that's the meaningful way to design this one. But again, for the sake of example, to make all my foreign keys the primary key of this table, I will make ID, course code, and section together the primary key of this table. But as I said, it could be also ID plus course code if you do not allow the same student to enroll to the different sections of the same course. So I'm going to hold my right key and choose these rows and right click and assign them as the primary key of this table. And now I'm going to save this table as enroll. Click on OK and close it. Close this one as well. I'm back to the main window. And if I open the enroll table and if I start adding something here, I will realize that I'm able to enter random data here, which is not a good thing because there is no student with ID 123, there is no such course, etc. And right now I did not link my different tables, that's why I'm able to enter random data. While you are creating the database, it is better to first start with the entities and then create the relationships and then define the relationships, which is what we are going to do now, and then at the end enter or populate your tables. So before I start entering something here, so I'm going to right click and delete these rows. Before I try to enter something into this relationship, I should define the constraints for it. So I'm going to close this and go into my main window. Under tools, we have this relationships option. So if you choose it, you have the option to include your existing tables. I'm going to include all three. You just double click on the table names and I'm going to close this dialog. So in here, in this relation design, we are assigning some tables as parents of other tables. And we do it by carrying attributes. So I have my attributes listed for the user table and for other tables as well. I'm able to drag these around to have a better view. And if you consider the relation between user and enroll is our relationship, user is our entity, but these are tables in base. And if you consider the link between these two things, to be able to enter some user into the enroll table, I want that user to first exist in the user table. So the user part is kind of acting like the parent. So my parent is user. A user should exist first in the parent so that I can add it into the enroll, into the relationship. I need to, while creating these links, I need to start from the parent side, start from the already existing one, drag this attribute into the related attribute in the child table. So in the case of a standard relationship, I start from entity into the relationship. If this was, for example, an aggregate relationship, I need to start from the relation that's inside the dashed rectangle into the aggregate one, the one that's outside the dashed rectangle. In case of an is-a relationship, I will start again from the parent into the child. So the direction that I carry the attributes is important. So I carry ID of user into the ID of enroll here. And this brings me this setting relation window. I see that my parent is on the right side, the child is on the left side, and these are the matching attributes. So I'm able to edit the matching attributes if I set something wrong. And we also have update cascade and delete cascade options in here. What this means is that If I change some primary key inside the parent table, for example, if I have a user number 5 and this user number 5 is enrolled to some course, let's say, and if I change the ID of user number 5 into 6, for example, if update cascade is selected, then it will also automatically change the number 5 in the enroll table into 6. So it makes our lives easier. Or if I were to delete user number 5, it will also delete it from the child tables. If we do not choose the cascade options, then we have to delete the user and then go into the enroll table and find the user's ID in the enroll table as well. In all of the related tables, you need to do it manually otherwise. So it's a good option to have. And when I click on OK, I see these two are now linked together. And if you want to go back to editing, you can double click on this link, editing. And for the course side, I would like to do the similar thing, but this time for two attributes, right? Because if I don't have these two attributes at the same time, I cannot go to the enroll table. When you carry one of them to the other, so for example, course code into the course code of enroll, I start again from the entity into the relationship. This is the parent, this is the child. If these are both the primary key, it works. Sometimes for some different setup, if you try to carry them and if it's not working, you can also open it from insert and new relation. So this is how we insert a new relation. In a minute we are going to see a case. For now, let me just carry the course code into the course code in enroll. But as it is, it's not fine. With just course code, I cannot find unique entries. I also need the section, right? That's why I also need to include the section. These two things match at the same time. And I also want the cascade and delete options. So I'm going to click on OK. I also see the other link here. So I'm going to save this relationship and close it and then open the enroll table. Now for enroll table, I set some links with different tables. If I try to enter some random data here, it will now not allow me to do. It says that, okay, for the parents in the user side, there is no such parent. It says that with this ID, there is no such user. So I have to enter an existing user. Maybe number 1 was an existing user. When I try to go out now, it says that this time on the course site, there is no such course. And then I have to enter some existing course. And these are like acting together as the primary key that chooses one course. So I also need to specify a correct section. Now I'm able to go out of this row. So what we did was actually to make sure that whenever I'm entering something here, let's get rid of this grade. Whenever I'm enrolling some user into a course, that user and that course should exist first in the parent tables. I can enroll the same person into different courses, and in the same course I can have multiple people. So these are specified by the primary keys of this table. But other than that, this is our relationship. So for example, I can assign number 3 to some other course with some section. I could enter some grade as well. But when I try to assign some non-existing user, then I have a problem. There is no user number 4. Then let's say I would like to cancel this row. Then you can press the escape key on your keyboard. So I see the pencil icon, let's say. I don't know what's the problem. I'm trying to go out of this row. Maybe I don't know what value should I enter. Then If you press the escape key on your keyboard, you just cancel this new data so that you have no longer an error. Any questions, problems about this one? So this is a many-to-many relationship. And in the case, let's consider if we wanted to make this a one-to-many relationship, what we need to do. Let me do it with a separate table. So I'm going to create a separate table now with a similar setup. So the field names are going to be ID. For the user's ID, it's going to be a number. And I also need the course code, which was text. And I also need the section, and let's also add the grade here. And section was a number. So in the case of a one-to-many relationship, if you consider this kind of thing, let's say I want to be able to assign one student to one course only. Let's say in a course there could be many students, but one student can enroll into just one course, at most one course. So let's say this is our case. In this case, if I make the user's ID my only primary key, then these could not repeat again. So it will be something like this. For the same course, I can have many users, but for the same user, for example, I cannot write 5 again. I cannot assign 6 again. I have to assign somebody else when I'm assigning them to other courses. So if I make the user's ID the single primary key, then I'm done with this one-to-many relationship. So in here, if I assign ID the primary key of this new table, I'm going to save this table as enroll underscore one-to-many. So in this case of a one-to-many relationship, if I would like to enforce this one-to-many thing, I can do it so by making only one part of the foreign key the primary key. So if I close this and open tools and relationships, so to include more tables here, I should go through insert and then add tables. So enroll one-to-many, I double click on this new table to bring it. So this is going to be a separate relationship between course and user. So these are very similar. For the sake of example, we are creating multiple relationships between these two entities, but this is again the child table. So for user, I start from ID of the user into the ID of this new relationship. And I also need to do the same for course code, right? But this time it will give me an error message because in here this is not the primary key, right? This I don't see this key symbol. So in such cases, I need both of these things. So that's, I believe, what causes the error. So I should go through insert and then new relation so that I can define the link. The problem is that to choose a unique course, I need course code and section at the same time. Since in this picture, these course code and section are separately also a part of the primary key, I guess it is not giving an error directly. But in this case, since these are not a part of the primary key, it directly gives the error. So that I need to go through insert and then new relation. My parents should appear on the right side, and on the left side I need the relationship. So course is on right side, and this new relationship enroll underscore one-to-many is on left side, and I need to specify what should match. So course codes should match, and also the sections should match. So the naming is helpful in this part. We just choose the same names, otherwise we might have to guess what to match. So when I click on OK, I have this relationship again. So I'm going to save it, and when I enter enroll one-to-many, this is my new table. For example, I can assign number 1 into CS281 with section 1. Then let's assign CS281 the student with number 2 to the same section. This is possible because the courses can repeat for this table, but let's try to assign the same student into some other course, for example, Math 1011. Then we will have a problem because it will create a duplicate value for the ID. So one-to-many is running successfully. We see that. I cannot assign the same student into two different courses. Any problems, questions? Sure. Uh, for that one, we cannot do it on the tables directly. So we need to keep track of the number of the courses that this student enrolls, and then on the implementation part, we need to like specify the limits. Otherwise, in here, we cannot do that. No problem. Any other questions, problems? So let's meet at 9:32. So any questions before we start? Now we know how to create one-to-many relationships, right? With relationships, how you set your primary keys influence your cardinality. In the case of a many-to-many relationship, all of the foreign keys are going to be the primary key. For one-to-many, you choose one side as the primary key. So when I talk about one side, what I mean is that you have foreign keys that references the primary key. And that foreign key could be just one attribute or it could be multiple attributes. For example, in the course case, we are using multiple attributes, right? And if I wanted to, I'm going into the edit of this new one-to-many relationship. If I wanted to repeat the students but not the courses, then what I need to do is to assign course code and section as my primary key. Then different people, then one student or one user can enroll to different courses, but for a course code, it cannot repeat with the section. For a course, this time, it will not repeat. So it will be, if you consider our example with dogs and the owner, then this time dogs will be the courses. Now dogs are the users because they cannot have multiple courses. There could be only one course for one user. And in the case of one-to-one relationship, I cannot have repeating students and I cannot also have repeating courses. So this is also not possible. If I want to have this line, it should be for a different section. So for a one-to-one relationship, foreign key for the user is not repeating, and foreign key for the course, these two things together are not going to repeat as well. As a result, actually one-to-one relationships are not that common. So with some examples, for example, if you try to find an example for a one-to-one relationship, those relationships can be reduced into simple attributes. For example, let's say I have a phone number, or let's say phone number table here, and let's say with a one-to-one relationship, I relate my users to phone numbers. Each user can have one phone number, and for one phone number there could be only one user. And with such a setup, I can simply add an additional attribute to my user table as the phone number. So that's why I mentioned that they are not that common, not that needed. But to assign a one-to-one relationship, let's have an example like that. So if the enroll table was 1 to 1, so now for that one, again, I'm going to create a new table in design view. This is going to have the similar foreign keys. So I need the ID, which was a number. I need the course code, which is going to be a text, and I also need the section number, which is going to be a number, and let's also include the grade here. Remember, we were saying that this should not repeat, and course code and section should not repeat as well. I have two unique things in my table. So when I'm assigning the primary key, I can make ID the primary key, or course code plus section could become the primary key. For the simplicity, it's better to use the single attribute as the primary key. So I'm going to assign my ID as the primary key. Right now, it is similar to the one-to-many case. But to make it one-to-one, I have to enforce that course code and section cannot repeat. I have to tell it to this database. So to do that, we have this index design here with the key symbol. If you click on that, it will first say that you need to first save the table. So okay, let's save the table. And for the naming, let's say enroll 121. So I'm able to get the indexes, and the existing indexes are used by the system for assigning primary keys, and when you create the relationships in the tools under relationships, these are creating automatically some indexes, and we should not edit those. So we would like to create a new index to make things unique. Otherwise, these are used by system, and it will cause an error if you change the things. So I'm going to create a new index, and you can give this any name. Let's call it unique ones. And for this index, so index is kind of like on the back end, when you add something, some data for these attributes, it keeps an index for them so that you can control whether they are unique or not. If you have some index, you can check whether the new data is unique or not. And what we want unique is course code plus section, right? Actually, ID was the primary key, so it's automatically unique as a separate thing. But course code and section together should be unique as well. And I will click on this unique button. So now course code and section together will not repeat. So I'm going to save this and close it. And now if I close this table as well, under tools and relationships, I'm able to include this new table. So it is enroll 121. And again, the same thing applies from ID of the user, which is the parent, into the ID of this new table, and course codes plus section to course code plus section of this new table. But again, I cannot carry them directly. It gives an error because I need to carry them both at the same time. It doesn't allow me to like choose multiple things and then I cannot carry those two things together. It only carries one thing. But to create a relationship, you can also use this insert and new relation dialog. And my parent should be on the right side. So this is my relationship. This is my parent's course. And the things that should match is the course code and the section number. I can also have the update and delete on cascade options. So this is my one-to-one relationship. So usually between two entities, you are not going to have the similar relationship, right? You are going to choose one of them, and this is the many-to-many case, one-to-many case, and one-to-one case. While you are connecting them, it's similar. Only difference is the primary keys of those tables. And when you go to the one-to-one case, this time let's assign number 1 student to CS281 section 1. In this case, I cannot assign the same student to a different course, for example. If I write this, then this will have a duplicate value for the primary key of this table, which was ID. Let's assign number 2 student to this course. And if I try to assign number 3 to some other course like Math 101 again, then again this time I have an error because this will create a duplicate value for the index unique ones. So this indexing unique ones is repeating again. That's why I'm not able to enter this row. So any problems, questions about these cardinality concepts? Okay, so in here, since we need both course code and section at the same time, when you try to carry just one of them, so if I try to carry one of them, you get such an error, right? Okay, so to be able to connect them at the same time, we should go through insert and then new relation. So because we have two things as the primary key, that's what causes the error, and we cannot carry them at the same time together. So using this relations view, then I'm able to, on the left side, it is going to be the child. So enroll one-to-one on the left side. And on the right side, it should be the parent, the course. And then I can choose this matching attributes at the same time so that we will not have any problems. Was it okay? Yes, yes. No problem. Any other questions, problems? Okay, so we are able to create different kinds of relationships, and with total participation, we do not enforce it directly on the tables. With some specific setups, you can combine tables. That's possible. But with a total participation, if you include the relationship table and entity tables as separate things, so for example, uh, for courses taught by teachers, you might combine multiple tables together. That will enforce total participation. But for the project, you don't have to do that. And without that, without combining tables, and with some setups, we cannot do it. We do not specify the total participation while creating the tables. In the later stages of the project, when we introduce the user interfaces, then we are going to use some methods to enforce total participation. And it will be like this. Whenever you create a new course, you will make sure that immediately you add some teacher as the teacher of that course. So we are going to use such an approach to uh, support total participation. Now we are going to start creating queries, and so that you do not confuse things. So we are just going to use the enroll relationship. The other ones were to show an example for different kinds of relationships. So we are not going to use them. We are going to create some queries on course, enroll, and user tables. So to create a query, we should go through queries, and then we have the option to create query in design view. We also have the option to use SQL directly. In the next lab, we are going to use SQL directly, but as an introduction, we will first start with the design view. And remember, queries are uh, used to get our data, to show our data in different ways. So I'm going to click on Create Query in Design View. And queries are including one or more tables. So I would like to have a query on the user table, for example. Then I need to include this user table by double clicking on it. I can include more than one table, but let's first start with just one table. I'm going to close this dialog. And this is basically my query design. In here, I can have multiple tables, and on the bottom area, I specify the things that I project. So each column here is a different attribute. On the table row, I choose the table. So I just have one table the user table for my query. So I can choose the user table, and the field part at top is specifying which attribute I would like to project. For example, I want to project names, and this visible means that it will show up in our results. To run a query, I have this run query option at top. I can also use the hotkey F5 on the keyboard. So if I run this query, it will display the results. So I had 3 users, Ali, Ayşe, Mehmet, and these 3 users show up in my results. Going back to this bottom area, I can include more attributes. So I might show the surname as well, for example. If I just directly click on the field, it's okay as well. It shows the table name and followed by the attribute name. For example, I might show the credits as well. And when I run this query again, now in my result set, I see those new attributes. I can save my queries. So to save a query, you can use Ctrl S, give a name to your query, click on OK, and I will close this one. So all my tables are under tables, and all my queries are under this queries part. So if I would like to go back into editing, I can right click and choose edit. And for each of the queries that I create in the design view, on the backend there is an SQL code that is generated automatically. To view it, I can also click on edit in SQL view, for example. And maybe I can make it larger. This is what I have there. So this is my SQL query, for example. It's making a selection from the user table. And one thing to realize is that in the SQL view, it automatically uses these double quotation symbols to mean that this is an attribute or a table. So while we are writing SQL directly, we can write such code for this query. So, but for this lab, we are not interested in the SQL code, so I will right click, and also if you double click or right click and open this query, it will display the results. But for now, let's go into the edit mode again. So this was my query design. So I'm able to show multiple attributes, and I also have this criterion row to specify some rules for my data to make a selection. But for now, I have not that many users. I'm going back into my user table. I will add a couple of users so that we will have more meaningful examples. So I add more data. Let's close this table, and when I go back into my query, if I run this query now the results are for this new state of the table user. And I said we can have different criteria for our attributes. For example, for credits, I can directly write 90, for example. When I run this query, it finds the users with credits equal to 90. So if you do not specify any symbol there, it is an equals sign. If I use the equals sign, it's the same thing again. I can use comparison symbols. I can say less than 90, for example. When I run this query, it will display the ones that are less than 90. Less than or equal to is also something that we can use. We also have the special symbol not equal to. So maybe from other languages you know the other ones, but this not equals is more of an SQL thing. So I can say not equal to 90, then I will get the ones that do not have a credit equal to 90. And you might realize that I have a bunch of OR rows here. This means that for this attribute, it is going to make the logical operation OR. So I might say for credits, it is less than 60, or it is larger than 100, for example, when I run this query, Ali is here because the credit number is less than 60. Esra is here because the credit number is larger than 100. I can also combine multiple attributes with an AND operation. So to do that, I will include this other credits column. And for example, let's make it less than 80. Let me first check it like this. So we have Ayşe less than 80, Mehmet and Ali. But let's say I also want them to be larger than 60. So on this second column, I can write larger than 60. On the same row, it makes the AND operation, so it will be less than 80 and larger than 60, or larger than 100. So when I run this query, Esra is here because it is larger than 100. Ayşe and Mehmet both are here because they are in between 80 and 60. They are less than 80 and larger than 60. So I can mix and match any number of such operations. And most of the time with these limits, for example, let's say I save this query, I would like to run this query. Sorry, I opened the wrong thing. Under the queries, it should be query number 1. I can display the new results for this query. But let's say I would like to change some of the numbers. In such cases, we have parameters. So I'm going back into the edit of this query. To define a parameter, we use the colon symbol. So anything that starts with the colon symbol is a parameter. We can have the parameter name. And again, it's better to use no empty spaces here. So I can specify, for example, a low limit for my query. Let's get rid of this larger than 100 for now. Let's say this query is going to show me the users that's in some credit range. And let's specify this as the low limit. So the credit numbers should be higher than this. And let's include some other parameter for this one, this time the high limits. So these are my two parameters. And when I run this query, I have to give a value to both of these things. So let's say high limit is 100. I'm going to click on next, or you can choose the parameters from this list. Let's say this is going to be the low limit, something like 70, for example. And when you click on OK, it will run the query, but I guess we made some, let me check the users. So we should have Mehmet, but I guess we have the wrong symbols here. So it should be less than the high limit and larger than the low limits. Some logical error that we made. Now I will run this query with the same parameters. And we have the results between 70 and 100. But whenever I run this query back again with different parameters, it will run for that parameters as well. And we are also showing the credits twice, right? And we don't need to show them twice. With one of them, I can make it invisible to the user. So if I make such thing, so let's say for this one, high limit is 60, low limit, let's make it 10. Then I have my result here. So I don't need to show it in order to use it. And by chance, it was only Ali. So let me make it a larger range so that we have more users. And if I save this query, if I run it directly from here, again, it will, sorry, not the user table, under queries, if I double click on this query name, it will ask me the parameters first so that I can use it. But let's say I do not write one of the parameters or any of the parameters. If you don't specify the parameters, if you keep them as null, then you do not have the results. So you have to give all of the parameters in such case. Any questions, problems with the parameters? So instead of writing a value there, you just use the colon symbol followed by the name of that parameter for the comparison. So going back to a new query this time, so queries, create query in design view, I will create a new query. This time I would like to include more than one table. So I'm going to double click on the user table. Let's say this was your older query. If you want to add more tables, you can do it so by going through insert and then add table or query. So you can get this window at any time to include more tables. And if you include enroll and course tables, since I already specify some link between those tables, I will see these relations. So I'm going to close this dialog now and focus on these tables. So these are the things that we specified in the relationships view. I can edit them here. These are making join operations. If I were to delete some of these links, it will not influence your original relationship. These are in terms of what we have in this query. And since these tables were related, it makes the join operations automatically. So for example, here under tables, I can have the username, for example, and from user, let's also display the surname of the user. And from the enroll part, I can display the grade, for example, but we did not have any grade for any of the enroll operations, but that's okay. And from the course side, I can show the course codes and course description, for example. Course codes, for course code, we are making the join operation. They are going to be equal. I can get the course code from course table, or I can get it from the enroll table. This is not important because I'm making the join operation already. These are going to match up. And for the ID of the user, for example, it is going to be the same because it is making a join operation. If I run this query, I will see the results. So with the user that is enrolled to this course, for this enroll, we had the grade. For the other ones, we don't have the grade. That's why we have them empty. But if I go back to my enroll table and add some grade to these students as well, when I go out of this table, if I run this query, now it will display the new results. So this is my query with a join operation. Any questions, problems so far? So in your project as well, you might have lots of tables here. And in one table, for example, we show the name. And for this user, I would like to show the description of the course that this user is enrolled to. This information is on a different table. And with the related tables, now I have access to both information so that I can show them on my results. So these links are making the join operation automatically. Let's save this query as query number 2. I'm going to create a new query under queries and design view. So let me include the user table and then the course table, for example. Direct link is no, so we do not have a direct link in between these two tables. So I'm not seeing any link. So I'm going to close this dialog. And for such setup, let's try to see an example. So on the So because user and course is not directly related, we need the enroll table to have the relationship. Mhm. So let's include the username, for example, maybe also user ID, and also let's get from the course side, course code and section. So if I run such thing, I will see this time lots of results. So in fact, there are 24 of them. And if I look carefully, all of the users, so I have 6 different users, all of these users is matched with CS281 section 1, and all of these users are matched with CS281 section 2 and with all of the remaining courses. So this is actually making a Cartesian product between those two tables, if there is no link between them. If there was a link, it makes the join operation. Otherwise, it makes the Cartesian product. So I have 6 users, 4 courses. That's why I get 24 results. I can define a join operation if I want to. In this picture, it doesn't make much sense, but if I want to, I can join section with ID. And in this view, since I'm not defining the relationship, so I can right click and delete this link, where I start from is not important. So it is going to make the join operation. We are not defining parent and child. And if you consider user and course tables, they are both entities. We don't need to assign one of them as parents and one of them as child. For this query only, we are specifying a join operation. And in here, only ID and section can match up sometimes. So ID and section can be equal to each other sometimes. This link is not that meaningful, but when I run such query, now for ID, if it matches with the section, I display those results. I make first the Cartesian product and then look at whether ID and section are matching, and for only those I show the results. Any questions, problems about this one? So if I don't have the link, it makes the Cartesian product between different tables. If I want to make join operations, if I want to define additional join operations, I can carry attributes into each other. But if I also say name should match with the course code, for example, nothing will return because we don't have any name that matches the course code. And to get rid of these links, you can choose them and hit delete key on your keyboard, or you can right click and choose delete. So I'm now going to get rid of the course table, but it's not deleting my original table. My original table is there. I'm just not showing or not using this table in this query. I'm going to insert an add table part, and I will include a different instance of the same user table. So usually with Cartesian product, we are inspecting something in the same table. And to do that, I need to include two different instances of the same table. With relational algebra as well, so you sometimes give different names to the same instance of the table, make a Cartesian product, for example, to find the highest number of age, etc. And in this case, I include two user tables to see what we have. So right now I don't have the course table, so I switch it to user underscore one. It's the other instance of the same table. Let's display the name here, and for user underscore one, let's also display the ID from this part. So when I run such query, I will see that again every user is matched with every other user. And on top of that, I can have some additional conditions for this. So for example, let's consider this. From user side, I would like to show the credits, and from user underscore one side, I would like to show the credits. So I have the user and user underscore one. They have both credits, and if I run such query, with the Cartesian product, I see that different matching credits. So sometimes I guess when I switch back to here, I somehow change the table name. So it was user underscore one, it should be coming from different tables. So one is the user on the left side, the other is the user on the right side. And I can define an additional rule on top of these two credits. So what I can say with the criterion on credits of the user, I can say it should be equal to the credits of user underscore one. And to do that, we refer to our table and attribute names inside square brackets. So I can write user in square brackets, meaning that this is my user table. That means that inside this table, again with square brackets, I have the credits. And actually I want this to be from user underscore one. So the different instances of this table, I have user and user underscore one. I want the credits in the user table to be equal to the credit in user underscore one. So my criterion is going to be this. So this credit should be equal to user underscore one dot credits. So if I run this query, now in my results, I only see when the credits are matching. So if it is the same user, the credits will match. That's trivial, right? For Ali, credit was 23, and if it is matched with the same user, the credits will match. But sometimes for different kinds of different users, for example, John and Jane, they have matching credits as well. Let's also say that I don't want to see the matching users. So sorry, let me say it like that. I don't want to see matching credits if the users are the same. Let's also add this as a different condition. So using the primary key is the better idea. For ID of the user, this time I want it to be not equal to ID of the user underscore one. So to say that it should not be equal to, I have to use this symbol. So for the ID column that's coming from user parts, this is going to be my condition. So if I run this query now, this time I do not see the ones for the same user. I only see if it is a different user, for example, John and Jane. And this time Jane is on left and John is on right. And if I don't want to see them twice also, what I can do is I can say that, okay, this should be larger than or less than the ID of the other part. So instead of saying not equal to, I can say larger than or less than. So when I run this query, this time I have Jane on left, John on right. So let me also add one additional user with the same credit amount. For example, if this was 19 as well, also let's maybe get someone else with 23. So if I go back to my query and run it again, so Jane and John has the same amount of credits, Jack and John, Jack and Jane, and Sinan and Ali. And I don't need to actually repeat the credits amount twice, right? I don't need to make it visible. Actually, I don't need to include it at all. So I can just choose this field name, and if I delete it with my keyboard, when I go into another column, it will disappear. So to be able to reference it with the criterion, you don't need to have it as a projection column, basically. I have this user underscore one table here, and that's enough to be able to refer it with the thing that we mentioned, the table name followed by the attribute name. What should exist is this table, and inside that table, this attribute should exist. Otherwise, you will have a problem. Right now, when I run it, it runs. But let's say I make a typo in here for credits. If I try to run it, it will give me an error. It will say that I cannot find this column credits with this letter 4 in it. So make sure that when you are writing your table names and attribute names, make sure that those are existing data. Otherwise, you will have problem. Any problems, questions? Mhm. Uh, so did you for which one? For this one or like any of them? Mhm. Yeah. Mhm. Oh, okay, I understand. So if this was user one, so let me do it like that. user one's credits are already equal to user one's credits. So this will be the same table then. And if I run it, since these are the same thing, it will display it for all of the users. But what we want to do is when two different users are matched up, we would like them to have the same number of credits. So from this part, so let me first remove this, and let's also include the user underscore one's credits. So when I run this, we know that it makes the Cartesian product, and inside these results, sometimes the credits are equal to each other. So this is coming from user, and this is coming from user one. And among these, I am interested in the equal ones, right? And for different users as well, sometimes it matches up. To have this condition, I can also, from the user one side, I can write here as my criterion, this should be equal to user dot credits. This is also okay. But it should be for users of different tables. Otherwise, the credits from the same table is already equal to itself. We don't need to specify the criteria. But if it is two different tables, when we say that these credits should be equal, then we are looking at something more meaningful. Is it clear? Okay. And so that we do not repeat the same user twice, we also write here, and we can also do it for like on the user one side as well. We can write here user dot id. This time we don't want it to be equal to, and if you use something like larger than or less than, then it is only shown once. Otherwise, you see the matching users once on left and once on right. Any problems, questions? So this is what we do for Cartesian product. In the projects, we don't really need it that much, but some more thing that we might need is to have some condition on text. So as a final thing, let me create a new query. For example, with the user table, let's get the username and surname and credits, for example, to project it. With numbers, you can have some comparison. You can use the larger than, equal, less than symbols. But with text, we need to use a special format. With text, we have the keyword like to use the relational, so to use regular expressions. So what is a regular expression? Any text is going to be a regular expression. So I can, using single quotes, write like Ali, for example. And for the names criterion, I can write this here. And when I run it, it will show only for Ali. And with regular expressions, we have two special symbols. One is the star symbol, meaning any number of any character. And we have the question mark. This means one of any character. And these can be included in my string. So for example, I can write like a star, and the things that will return for this are going to be AB is true for this. So this time star is replaced by the character B, one of character B. ABB is okay for this one as well, 2 of B. We might have something like A followed by lots of different letters. Any number of any characters, this is valid for it. But we cannot see any BA here because I specify that A should be the first letter. So let's try something like this. If I write it here and run it, I will see the results with name starting with the letter A followed by anything else. I can For example, also include the star symbol at the beginning. Then all of these are still valid. If I have only A, that's also valid as well, because I'm saying that it can be any number of any character. No character at all is also possible. I can have just A as well for both of them. I can also have some other characters at the beginning. So this time BA is okay as well. And whether your data type is case sensitive or not, according to that, small letter A's are returned or not. So in our database, name was not case sensitive. So in here I can write like inside single quotes star A star. So let me make it larger so that you can see it better. So this is what I wrote there. It is going to be equivalent to this one, because if you remember, let me show it quickly. In our user table, if I go into the edit, the name is text with an ignore case. We also have the other version of the text. If it is ignore case, then the lower letters and capital letters are the same. So for Ali, it returns with the capital letter at the beginning, but for Jane, Esra, etc., it also returns true. With the question mark symbol, what we do is we kind of specify the length of our string. So we can write something like this, like 4 question marks. And each of these question marks can be replaced by some character, but they have to be replaced by something. So for this one, I cannot have ABC because there are only 3 letters. A, B, C, D is okay. 4 A's are okay as well. So this is used for finding the length of our name. So if I run it like this, then I will see only the ones with 4 letters in their name. And I can mix and match these characters. For example, I can say 4 characters followed by anything. So I'm specifying that it should have at least 4 letters, but if it is higher than 4, it's also okay. So for this one, for example, I can have 4 characters followed by any number of other characters. But if it is 3 letters, it's not okay for such thing. So let's run it to see it. So if I run it like this, now Mehmet is also included because it has more than 4 letters in it. And you can have something like this. For example, do we have any part that repeats together? Well, not really, but for example, this is also okay. You can have things like there can be any number of any characters followed by, for example, H and N, for example, followed by anything. So you can have multiple letters in it. Or you can say there should be an A that's followed by an E, for example. And in between those letters, there can be any number of any characters. If we run such query, then we see Aisha and Jane because A is followed by an E letter with any number of characters in between. So most of the time in our projects, we are going to use this to find some data that begins with some letter, for example, most of the time. And with regular expressions, you can have much more complicated expressions, but for this course, knowing this much would be enough, I guess. Any questions, problems? So then that's it for today. And in the other labs, so also don't forget that the labs are not in every week. So we have our schedule here, and in next lab we are going to write our SQL queries directly, and we will have kind of more power in the design view. We can do things in a visual way. It is kind of easier to do it so because it is hard to make mistakes. With SQL queries, you might you are more prone to mistakes, but then you have more power. You can do additional things easier. And remember, for every query that we create in the design view, there is a corresponding SQL code generated. So for example, for this one, there is this code generated. And this might be longer than what we would write if we were to write it directly in SQL. So it automatically generates it, and because of that, it might be more crowded than it is needed. So if I bring it here from the classes, so this is following some structure of selecting from with some where conditions with and operations in between. So this is basically uh, from these three tables, it projects these attributes and it makes the join operations in between different tables. So if we do not have any questions, then we are done for today. Thank you. See you. Görüşürüz.